Good evening everyone. Today we are going to do the daily lead code challenge of 12 February 2023. That is question number 2477. The minimum fuel cost to report to the capital. There is a tree. A tree is a connected undirected graph with no cycles. Structure country consisting of n number of cities numbering from 0 to n minus 1 and having exactly n minus 1 roads. The capital city is city 0 and we are given a 2D integer roads array and we are given there exists a bidirectional road connecting the cities. Okay, and there is a meeting of representative of each city. The meeting is in the capital city. Okay, there is a car in each city. You are given an integer seats. Okay, a representative can use the car in their city to travel or change the car and ride with another representative. The cost of traveling between two cities is 1 liter of fuel. Return the minimum liter of fuel to reach the capital city. So the question wants you to return the minimum number of liter of fuel required to reach the capital, and they have given you some seats, and some of the representatives can do carpool in some cases. So without further delay, let's move on to the example. So in the first example, they have given you road is from 0 to 1, 0 to 2 and 0 to 3 and seats is 5. So in this question, if we have to draw this graph as it is a form of tree, because it is a tree according to the question, we can draw it like 0, 1, 2 and 3. As there is no cycle possible, we can draw it like this, and bidirectional movement is possible. So we have to return the minimum liter of fuel required. So it will take 1 liter, it will take 1 liter and it will take 1 liter. So total is 3 liter of fuel. Simple. Now let's see second example. Again let's draw this in the tree pattern. That is 0 is here, then we have 1, then we have 3, and then we have 2, and then we have 5, and then we have 4, and then we have 6. So now what we have to do, we have to find the total amount of fuel. So it will take 1 liter of fuel, fuel will be 1. It will take 1 to reach here, and from here, as it has 2 seats, these two can go together. So it will give 2. So total also 1, then 2. So total 3 liter of fuel by these two nodes. And when we go to this subtree, what we can see, we already have 3 liters of fuel. It will take 1 liter to reach above. Then these two can go together as it has two seats. Then 1 liter to go here. Then from here, 3 and 2 will go in single car, that is 1. And 1 will also need to go there, so that is 1. So total how many? 3, 4, 5, 6, 7. So total 7 liter of fuels is required in this case. So how do we do with this question? So if you see this question, you can simply tell first step was to change this tree into this format, so we can look at it better in a better way. And when we see this tree, we can see that we can apply a depth first search to get the depth. As bidirectional movement is possible, instead of going from bottom to up, we can also find the same distance from top to bottom, and that can be our answer. Let's see it in other example. So here you can see that if we draw this again like this, that is 0, then 1, then 3, then 2. Here we have 5, and here we have 4, and here we have 6. So what we can see that if we have to find it by depth first search, what we can do, instead of finding the distance from bottom to up, we can find it from top to bottom. That parents distance to its children, we can find it, and we can do that by depth first search. So how do we deal with this seats condition? Because that won't be optimal in every case, because not everyone can come with single unit of time, that is single liter. So we have to consider this seat situation. So what we will do, if we notice, it will take 1 unit of time, it will take 1 unit of time, and it will take 1 unit of time. There was no issue in simple cases like this when there was 1 unit of time. But when they have children and when they have branches, we have to consider this seat situation. So what we can do, we will make two variables. One is fuel. So if we divide it by 2 or divide it by number of seats, in general case, here it is 1 by 2, that is 0.5, and if we take the ceiling value, CEIL, ceiling value, that is upper value, it will be 1. So it will return 1. Same goes here and same goes here. So now if we think about it, we can take the ceiling value and we can take the total number of passengers required. So we can get our answers. So how do we do that? We will make two variables. One is fuel, other is a number of passenger which will count the passenger. So let's dry run this. So for that we have drawn this, that now we will take a variable, global variable fuel, which will mark the fuel which will be returned to our answer, and we need to get the total number of passengers. And let's say in this case seats number was 2, seats is equal to 2, we are given 2 seats. So how do we do it? So we will ask how many children do you have, or how many passengers you have. So how will they tell it? When we go to this node, it will say I don't have any passenger, but I am myself a passenger, so I will return 1. So 1 passenger. And how do we get the fuel? We will get the fuel by passenger divided by seat, P by S. So that is 1 by 2, that is 0.5. And we will take it ceiling value. Ceiling value if we have taken, it will become 1. So first fuel is 1 from this node. Okay, very good. So now we have to check for this. It will say, let me ask my children whether they have whether they have passenger or not. It will say I don't have any passenger, but I am myself a passenger. So it will return 1. So it will return 1. So it has 1 passenger. So for traveling this distance, it will require fuel. So 1 by 2 is again 1. So 1 fuel is required. Then when it reaches here, it says I have 1 children and I am myself a passenger. So it will become 2. So 2 by 2 is 1. So another fuel is required and it will become 1 plus 1, 2. So passengers becomes 1 comma 2 and fuel become 1. Total fuel is currently 3. Okay. So this is till now. Now when we move on to this branch, it will say let me ask my children. It will say let me ask my children. It will say I don't have any children or passenger, but I am myself a passenger. It will return. When it return, it will 1 passenger is returned and it will require fuel will be 1 3 plus 1 is for this. 1 by 2 is 0.5 and 0.5 ceiling is 1. So 1 fuel is required to travel from 2 to 3. Then 2 will combine, which is that I have 1 children and I am myself a passenger. So it will become 1 plus 1 passenger and fuel will become 2 by 2, that is 1. So 1 is also added. It will return 2 to this and 1 say I have 2 children and 1 I am myself a passenger. So total passenger will become 1, 2 and 3. 3 is for this node and it will say that we have to return above. So how do we do it? 3 by 2 is 1.5. Ceiling value is 2. So it is 2. So fuel will become 3 plus 4 plus 5 plus 7. So total fuel becomes 7 as an answer. So that is how you do this question. You will divide the total number of passenger by seats and you will take the ceiling value. Because here when they have reached here, only one person can go solo and other two can do a carpool. So that's why 2 liter of fuels is minimum required. That is what we have done. So this is all you have to do. Let's move on to the code and code this. It is very simple. If you have understood this dry run, please practice it and let's move on to the code. Now to code this, as I told you, we will have a global variable long result as an answer. Let's initialize with 0. And why long? Because data type is already long. That means they have a very huge test cases possible. It is fuel, final fuel, minimum fuel required. Now to start this, we have to convert this array into a tree, and for that we need to make a adjacency list. And how do we make an adjacency list? We made it like this. There are other ways to make adjacency list, but I like this way, so I'm drawing it like this. And now we have to make undirected graph. That means we have to, for auto x2 roads, we will iterate in the roads and then we will push it in our adjacency list. Push back, and as it is bidirected, we also have to push adjoint x1 push back x0. This forms a bidirectional relation in our adjacency list. So it is done. After that, what I told you, we will apply our DFS. In DFS, we will pass our child node, we will pass its parent, and 0 parent is -1. We will pass the adjacency list and we will pass the total seats. And when we are done with all this, we will finally return our result. So let's implement this DFS function. So DFS function is implemented. So DFS function data type will be DFS, integer, because we are returning number of passengers after DFS calls. Let's see. So first is int child, or we can write it as int node. Then we have int parent, and then we have this whole adjacency list, and we will pass it by reference so that we do not create any copies and do not face any time complexity or memory issues. And then we will pass our seats. We have passed this. Now the DFS process remains same. The body overview remains same. So let's declare a variable passengers, that is total number of passengers or people which will be traveling. Then we have to apply DFS. How do we apply DFS? For auto x to adjacency node, we will iterate through every node. And we all they have given that there is no cycle possible, but we also have to check for the parent, that if we have visited this node, it is parent and it is child. We should not visit it again and do not form a cycle. So we will check if x does not is equal to parent, then we will store our number of people. It will ask its children, that is, it will ask its children how many. So for 3 it was 1. So what is that? So that is people, or you can say int p, let's say write people. In people is equal to, we will apply DFS. If the current node is not equal to its parent, that means we can apply BFS. So we will pass, and now the node will become parent, and we will pass the addition list, and we will pass the seats. So that is how our DFS is traversing. And after that, we need to add it to our passenger. Passenger plus is equal to people. So that will be the total number of passengers. Now after that, we will add the fuel, as we were adding fuel at every step. So how do we calculate our fuel? Result will be seal multiplied by people into 1.0. This is to change the integer into data type, so we can divide it by seats, not 2. And 1 is multiplied to change it into float, so we can get the ceiling value. Or you can also do outcasting, it is up to you. And after we are done with this, we will return our passengers plus 1. Why plus 1? Because it is saying that I have 1 children. It is saying I have 0 children, but I will include myself, so it is passing 0 plus 1. When 3 get this 1, it will say I have 1 children and I also want to travel, so it will return 2. That's why this plus 1 is there. So I think it is done, and it should be capital P. I think it is done and it should work. Let's just run and submit this. So yeah, it is running for all the cases, and the time complexity will be O of n, as we are calling DFS. Let's submit it. And yeah, it is accepted. So yeah, it is working. So what we notice is the time complexity will be O of n, as we are calling DFS, and in the worst case, space complexity will be log f n if it is a balanced tree, and O of n if it is an unbalanced tree, because we will be using stack in a DFS. So that is all for this video. Thank you so much for watching. I hope you liked the video. Please like, share and subscribe. Thank you so much for watching. Bye bye.